Business Finance, Chapter 11 examples. In Chapter 11, we look at calculating expected returns for individual stocks and expected returns for portfolios. We're going to look at some examples where we do those things. This first example is a portfolio, and we want to know what the total portfolio value is, and then what the weight of each stock is. So the value of A, the value of B, the portfolio value, and then how much is weighted in each. So just the value of A and B is the number of shares you own times the price that was paid for them. And for B, the number of shares of B times the price we paid. If we add those amounts together, we get the total value of the portfolio, which is $17,475. We then want to know how much of the weight of the portfolio is from stock A and how much is from stock B. So we take the value of each stock divided by the total portfolio value to get the weight. So the value of A divided by the portfolio value means that 67.75% of the portfolio is made up of stock A. And then the value of B divided by the portfolio value. You could also take 1 minus A because you're trying to get what is the remainder of the portfolio. So then 32.25% is made up of stock B. Example 2, we have a portfolio. We're given the value of A and B, and we're given the expected return of A and B. And what we want to know is what is the expected return on the portfolio. So first, we are going to have the portfolio value, which is stock A value plus stock B value, so the total portfolio value. We then want to know the weight of each within the portfolio, so the value of A divided by the portfolio amount and the value of B divided by the total portfolio value. Now to calculate the expected return on the portfolio, you take the expected return for the stock times the weight of the stock in the portfolio and then add those two results together. So the portfolio expected return is the expected return on stock A times the portfolio weight of A plus the expected return on B times the portfolio weight of B. So the expected portfolio return is 11.89%. This next example, our portfolio is extended out to 3 stocks, and we're given the weight and the expected return. So as you can imagine from our last example, to calculate the expected return on the portfolio, we need to take the weight of each stock times the expected return of each stock and add them together. So for the portfolio expected return, we will take the weight of stock X times the expected return of stock X plus the weight of stock Y times the expected return of stock Y plus the weight of stock Z times the expected return of stock Z. We then get an expected return on this portfolio of 13.05%. In 4, we're given the portfolio value and the expected returns. And what we want to do is calculate the weight and how much of that $10,000 is invested in stock X and how much is invested in stock Y. So first, we want to find the weight of stock X. So we have, we're going to take kind of the opposite of what we did for the last two. So we have the portfolio return minus the stock return of Y divided by the stock return of X minus the stock return of Y. And then the weight in stock Y is what is left over in the portfolio to make it to 100%. So that is 1 minus the weight of stock X. Now to calculate how many dollars we have invested, we take the total dollar value of the portfolio times the weight of each stock. So total value of the portfolio times the weight of stock X and the total value of the portfolio times the weight of stock Y. So this tells us how many dollars of our total portfolio we have invested in each stock. We're going to calculate the expected return now, looking at the probability of a return in a recession versus the probability of a return in a boom economy. So we have two different economies here. We have a recession economy and a boom economy. Out of the 100% total, we have a 30% chance of being in a recession and a 70% chance of being in a boom. If we are in a recession economy, we're going to earn a negative 13% return, and a boom economy has a 70% probability of earning a return of 21%. So for the probability and return, we're just bringing the information from the above so we can do calculations. So you take the probability times the return associated with that probability. So the 30% probability of a negative 13% return and a 70% probability of a positive 21% return. And so the expected return is the total of those two together. So we have an expected return of 10.8% on the stock that is being talked about in this example. In this example, we have two stocks and we have a recession economy, a normal economy, and a boom economy. And we want to know what are the expected returns and standard deviations for the two stocks. So we're going to start with stock A. This is similar to the examples we did for chapter 10. We're just including these probability factors into it. So we're going to bring down our probability information so we can do calculations and the information about our return. So we take the probability times the expected return for that probability, and we add them together, and that is our expected return for any given time for stock A. So given all the probabilities of each event happening, we get a total expected return for stock A of 10.55. Now that we have the expected rate of return calculated, we figure out the return deviation. So that is the difference between the return and the expected return. So the expected return works like our average return did in chapter 10. I'm going to lock that cell so we can copy it down. We then have our standard deviation or squared deviation calculation where we take the return deviation to the power of 2. We copy that down. And then the last result is the product times the deviation squared, and we'll need to, if we want to actually see numbers for that, we'll need to extend that out a bit. Copy that down, and we want to add them together for our variance. And then remember the standard deviation is the variance squared. So we do the square root function of our variance. So we have the expected return and the standard deviation of A. We do the same thing for stock B. So we bring down the probability for our different economic states. We bring down the potential for returns for stock B in those economic states. We then take them, the probability times the expected return, so that we can calculate the overall expected return, which is our average potential return. Our return deviation is the difference between the return and the expected return. So we'll lock that expected return cell so we can copy that formula down. Our squared deviation is the deviation squared to the power of 2. Copy that. And then we have our product times the squared deviation. So it's the squared deviation times the probability of it occurring. Copy that down, and if you want to see the numbers, I'm going to extend. We add those together to get our variance. And then the standard deviation is the square root of our variance. So now we can see that stock B is more volatile than stock A because of the significantly higher standard deviation. We also know that the more risk you take on, the higher potential of return. So the expected return on stock B is higher than the expected return on stock A. Okay. Now we have information about the weight of stock and the betas for stock. So remember, the beta is a measure of risk for stock. That average risk has a beta of 1, and then anything below 1 is a lower than average risk, and anything above 1 is a higher than average risk. So it's an indicator of risk. We want to know what the portfolio of the portfolio beta is. We need to take the weight of each stock times the beta of that stock and add those results together. So we have the weight of stock Q times the beta of stock Q plus the weight of stock R times the beta of R plus the weight of stock S times the beta of stock S plus the weight of stock T times the beta of stock T. And that result gives us the overall beta of our